Hello and welcome to this video. My name is Brandon Becker, Product Line Manager of Industrial Wide Bandgap at Semiconductor. Today, we're going to talk about utilizing wide bandgap in server and industrial power applications. For wide bandgap, we have three focused markets. Today, we're going to talk about power supplies. Currently, power supplies are a $30 billion market. Today in the US, 3% of energy is used to power servers and storage racks. This is expected to grow to 15% over the next 20 years. If we take an in-depth look at the server and industrial power market, you can see that it was a $23 billion market in 2016, rising to a $31 billion market in 2021. The netcom, datacom, and industrial power is driving power density, which is needed for the cloud and 5G computing. Silicon carbide diodes are used in the PFC stage, as well as GaN and SiC FETs are becoming the choice for totem pole and LLC stages. Now, if we talk about this figure on the upper right-hand corner, really everything comes down to efficiency, which is the 80+ standard, as well as power density. Designers today are focusing on meeting an 80 titanium standard, as well as increasing the power density. Standard density is about 5 to 15 one-unit servers, ranging from 2 to 4 kilowatts. But really we're pushing the envelope, moving to ultra-high density, 4 to 6 blade servers, those are interchangeable servers, from 15 to 30 kilowatts. These trends, these power levels, these efficiencies is what is driving the server and industrial power markets. Now let's take a deep dive into the server and industrial power topologies. Here we're going to focus on the PFC, where the input voltage is typically somewhere between 220 volts to 230 volts AC, and the output is usually about 400 volts DC. The conventional topologies with silicon PFC solutions included a CCM, or continuous conduction mode, dual boost, or full bridge topologies. The disadvantages to these is the best efficiency you can achieve is around 95%, most of it being under 95%. You have limited switching frequencies because of multiple inductors and high component counts, which in turn give you a large footprint. Silicon carbide enables the PFC to move to a totem pole or flyback topology. Some advantages of these topologies include higher efficiencies, hitting 98%, increased frequency, increased power density, bidirectional power flow, and reduced component count. In summary, wide bandgap is the solution to all engineers' problems. It really does three things. First, size reduction. The whole system is much smaller, moving from silicon to silicon carbide. Second, it's an efficiency and performance improvement, and we see up to 73% reduction in losses. Third is cost. We can see today that the cost of a system is actually cheaper at a BOM level than a silicon solution. Now that we've gone through what silicon carbide is, how it's manufactured, some of the benefits that go along with that, let's take a look at Semiconductor's portfolio. We have a very large portfolio that range from diodes to MOSFETs. Our diodes include 650 volt and 1200 volt through-hole, surface mount, die, and modules. Our MOSFETs are released at 1200 volts with 900 volts and 650 volts coming in the near future. All of our products have high level of quality and reliability, which include undergoing AEC-Q 101 testing. Thank you for tuning into this video about power supplies and industrial power. I hope this information was helpful, and if it was, please tune into our other focus market videos. Of course, if you have any questions or want to find out more information, please visit us at onsemi.com.